Let's get going. Hopefully you had a good weekend, and hopefully the virtual lecture went okay. We're going to talk about UML today. We're getting close to the midterm. So this is one of the big parts of the midterm. I would say this is the last big part on the midterm, which is going to be drawing diagrams for the code that we're writing. Okay, after this, we'll review some small stuff as we get up to the midterm, but I would say this is the last large section of the midterm. Let's see, the lectures may be numbered wrong. No, actually they're correct. Let me move this up to Module 8. Okay, we're on lecture number 20. There's a few slides we're going to go over before we get into drawing UMLs. Just go over the basic concept. And then we'll open up Draw.io, which is what you need to do for the challenge. Okay, here we go, lecture 20. UML is Unified Modeling Language. Okay, there's actually a lot of different UML diagrams that we can draw. These slides are referenced from this reading here. Essentially, UML is a way where we can draw the architecture of the application. So for example, we got into Model View Controller, we saw the different components, and we saw we were drawing some diagrams so we can see the architecture there. So we had 3 components, and we talked about the communication between those components. If I just start talking about MVC and not show that diagram, it may be very difficult to understand what's happening. With a diagram, it makes it a little bit more easier. So UML is a way to draw down these architectures between object-oriented programming. So we can see this example here. So let's say we have a person class. Okay, so we have a lot of people. More specifically, we may have a Mizzou student. Okay, so there's some relation there between people and a student, because a student is a person. And you may get even more specific, like a 3330 student. So I have some relationship there. You'll see a hierarchy going up the tree. Person is the most generic. And as I go down the tree, it gets more specific. Okay, you can see a bunch of different examples there. So by looking at this, I can see I have 3 classes, and I can see some relationship in between them. So a lot of people are wondering, well, why should we learn UML? What's the big deal about it? Is it even used in the industry? What kind of information goes into it? Okay, we'll be answering some of those questions. Usually when you're developing software, you have the design phase. So I don't know if you've taken it yet, but you will here shortly. You'll get into software engineering. And the design phase is going to be one of the most important phases. Actually, at the Google interview, they said that they were looking for people who actually talked about what they're going to do before they start implementing it. If you ever go to the Google interview, it's very stressful, so you immediately want to start coding. But that's actually the wrong move. What you want to do is you want to step back, think about the architecture, think about how you're going to solve that problem, and then start coding. So you're going to have that design phase. Now, during that design phase, you're going to specify the structure of how software will be written. Okay, so if you're given a problem, step back, think about it. How am I going to solve this problem before you actually start implementing the code? Now, I've seen some people write some pseudocode or draw the diagrams like we're about to do today. Essentially, you just don't want to write the complete implementation because that'll take some time. Okay, in the design phase, you're more talking about what the system's going to do instead of how it's going to do it. So let's say I want to have 3330 modeled in Java. So I would think, okay, I'm going to have a person class, and there may be students at Mizzou, and I may have students in this class. So I can already think about some relationship before I implement it. So you'll think about what fields, what methods will each class have. How are they going to interact with each other? What classes will we need to implement this system to meet the requirements? So a big one we're going to look at is class identification. There's a bunch of different UML models that we can draw, but we're mainly going to focus on class representation, class diagrams. Okay, let's see. Let me scroll down a little bit. You'll see a bunch of uses. Hold on. Right here. So here's all the different types of diagrams we can do. You can do class diagrams, object diagrams, sequence diagrams. These are all very popular. And these are all cases of the union of modeling language. Okay, so I have all these different types of diagrams that I can do. The main one we're going to focus on is class diagrams. So you see I went over a few slides there. Talks about who invented UML. These are good quiz questions. Okay, so let's specifically talk about class diagrams. So a class diagram is exactly what it sounds. It's going to be the class in the object-oriented system. We're going to draw their fields and methods. Because if we think about a class, we have a class. The class could extend other classes. There's some relationship there. It can implement an interface. And essentially all you have is fields and methods. So that's all we're going to draw, the relationships and the fields and methods inside that class. Now what's not in a UML is going to be details of how the classes are going to interact with each other. You'll see some connection between the classes, but we're not going to represent all the details. And we don't care about the algorithm details. We don't care about really what that function does, what that method does. We just want to know the method's there and it exists. So it's a very high-level diagram. Okay, these are textbook definitions here. So a class represents a discrete concept within the application being modeled, representing things of a particular kind. Okay, because that's what a class is meant for anyway. So you have a physical thing, like an airplane, or an order, like a business thing, a logical thing, broadcasting. So that's what we developed classes in the first place. If you go back to one of the first lectures, we used examples in the class. So we had the door, we had the projector. Okay, so that's what classes were modeled for to begin with. So that's how we're going to represent them in the UML diagram. This goes back to our definitions. What was an object? An object had states and behaviors. Okay, so this is going back to the basics. So we're going to draw those states and behaviors. Let's take a look at an example. So here's exactly what we're going to be drawing for the challenge. You see I have this box. Okay, at the top of the box is the class name. And then I'm going to have the fields. Now you notice in UML it's a little bit different. I specify the name, and then I specify the return type. And in a lot of programming languages, this is actually the correct implementation to specify the name and then the return type, like in TypeScript. So you'll see series is a string. Price category is a category. That's not a built-in object, so we know that's a class. Then I have number as an integer. Integer's built in. So then you'll see I have another compartment here. Here's my cost method that returns money. Okay, and then I have another method. You'll see it has two parameters. Series, which is a string, and level, which is a seat level. And I have cancel. Cancel, you'll see, has no return type, so that's a void return type. So you'll see I have a lot of information about this class here, but it's not too much information. I don't know how the cost method works. I don't know the implementation details. I don't know how it works, but I know that it's there. So I know what the class consists of, but not how it's implemented. Okay, we saw the class name goes at the top of the box, and there's all these different rules. So this is where it becomes difficult. So if it's an interface, I need to write the interface annotation at the top. So you'll see these two little brackets. These are special brackets. We'll look at it when we get implementing here soon. You'll see italics is for abstract classes. So if it's an interface, I do the annotation. If it's an abstract class, I make it italic. Okay, you'll see some examples here. So you'll see I have an underline. Okay, underline we'll get to in a little bit. That should be static. You'll see different annotations here. So here's a minus. Okay, here's a plus. So minuses are private, plus are public. So here I have a private field and a public method. Okay, here's some more rules. So let's say I have a field up at the top. You always put the name and then the type. You'll see the visibility is in front as well. So if it's public, private, protected, or default. Then if it has a default value. So let's say I was doing pi. So I'd say pi is a double and its default value is 3.14. Okay, so I do something like that. You'll see I have all these different visibility features. Plus is public, minus is private, hashtag is protected, curly brace is the default. You'll see you underline static attributes. And those are these examples here. So you'll see, again, here's my private field. Here's a public method. You'll see the constructor's public. This method has the same name as the class, so that's my constructor. Here's a field that's underlined, so that's going to be static, and so on and so on. Okay, so we're going to draw all these, and that's just inside the class. So we also need to show the connection between them. Okay, so pretty much same goes for a method. Here I'll have the method name, followed by the parameters, followed by a return type. Okay, so it's pretty much the same as what you'll see in the code. The only difference is the return type comes after. So we could look at this constructor. Here's the visibility. Here's the name. Then in parentheses, I have the parameters. Parameter goes name and then return type afterwards. Constructor doesn't return anything, so I didn't put anything back in the back. However, distance here returns a double. So a good rule of thumb is you want to try to put as little information as possible. So I don't need to put a void return type here. So I want to omit the return type if it's void. Go ahead. Yep. Yep. That would be the variable's name. So the variable's name is R, and the type is of rectangle. So that variable R could be anything. We can put that variable as anything, and then the return type is rectangle, which will be the type of the class. Okay, good question. You'll see static methods are underlined just like the fields. If it's abstract, it'll be italic. So we just have to learn these rules, and then it'll be easy to draw the diagram. So I have a nice reference for you to use called uml.pdf. Now there's two types of relationships that we're going to be mainly focusing on, unless there's an enumeration, which then you have to look at some others. We have one called generalization, which is going to be inheritance. And then we have association as well. So generalization can have inheritance between classes and also interfaces, okay, which we'll see in the example. Then we have association. which we'll talk about all the different types of association. So now we have the class diagram figured out. So we got some rules. We got to follow the rules. Underline, italic. It's kind of hard to write italic on the midterm. So you can write an annotation like this to show it's abstract. Okay, because it would be kind of hard to write sideways. On the challenge, you could just use italic. That's fine. So here I have an interface called shape. You'll see it doesn't have any fields, but it does have a public method that returns a double. You'll see I have a generalization here. I have inheritance. This class is going to implement the interface. And I have rectangular shape and rectangle. You'll see an arrow here. So the solid black arrow is going to represent extends, and the dashed the dashed line will represent implementing an interface. Okay, so here I'm implementing the interface, and here I'm extending the class. But you'll see there's a little bit difference here. Okay, if it's an abstract class, I have a white arrow. You'll see this class is italic. If it's a concrete class, I have the black arrow. Okay, you'll see a little different arrow annotation up at the top. Okay, now it gets a little bit different when I have abstract methods. So let's have an abstract method. You'll see here abstraction is italic. So here's an abstract class called order. I have an abstract method called confirm. So what you'll do is you'll write it in the abstract class as italic, and you'll see mail order is going to override that method in the subclass. So up here it'll be italic, and down here it won't. So it shows that this concrete class overrides the confirm method in the abstract class. So that's how I can determine whether it overrides or not. Abstract, we went over on Friday. Abstract means it's a method without any implementation. So it's just a method signature, and then you need to provide the implementation. Pretty much. It's right in between. So I have my regular class, I have an abstract class, and then my interface. Yep. So an abstract class can have 0 or more abstract methods. But in interface, usually they're all abstract. But in some rare cases, they're not. Okay, so you'll see I have my arrow here. So this class extends order and overrides the confirm method. So you'll want to write it in both places. One place is it's italic. The other places it's not. Okay, which shows the override annotation. Okay, and then we get a little bit deeper. So now we have association. Now with the challenge that you're going to do, there's probably only one example where you'll need to use this. But you can break it down even further. So you could say we have class A, class B. So you'll see this 1 dot dot. So it's going to be one or more. So class A contains one or more class B. Okay, you can see some relationship here. So association would maybe whether the class uses it or not. Uses it would be like if I create an instance of that class. Go ahead. K is any number. Okay, any number. So let's take a look at a more concrete example. So here's a one-to-one. So if I had this type of relationship, I may say each student must carry exactly one ID card. Okay, so I have one student and one ID card. Or you can say here, one rectangle list can contain many rectangles. So you'll see I have one rectangle list, and then I have my star over here. Okay, the one that you're going to be wanting to look at are one of these. There's actually four. Let's see, is there one? Okay, I'll show you in the other example. Actually, let's go to the other example. Let me show you the PDF example of what you'll be using on the challenge. So here's uml.pdf. So I like the first one because it kind of explains things in more detail. And the second example is actually like some coding examples, what we go over in class. So here I tell you static members are underlined, abstract elements are italic. Here's all your access modifiers. Plus is public, minus is private. So this is kind of like a good reference sheet. So you pull up your challenge, you pull up this reference sheet, and you see if the example's there. You can't see that? Okay. Yeah, it looks like it's not up, so. Which is kind of weird because I could see it. Okay, yeah, let's see. Okay, try it again. You see it? Yeah. Okay, thanks for letting me know. And you'll see here, so I gave those exact examples. You'll see it starts with the access modifier, then the name, then the return type. Same with methods, so I give an example. Here's a constructor. One thing we didn't say is the constructor uses this constructor annotation. So you specify it's a constructor just like you would if it's an interface. You'll see interfaces give this annotation. Enumerations give this annotation. So like I said on the in-class midterm, you will draw a UML diagram. And since it's hard to write italic, you can also put the keyword abstract annotation. So here's the relationships I just got done talking about. So see A generalizes B. B is a subclass of A. Okay, in Java, B extends A. Okay, you'll see the superclass is always on top. So if I have superclass, subclass, superclass is always on top. Arrow always points upwards. Okay, to show that relationship. Same with interfaces. Okay, B realizes the interface defined in A. So in Java, B implements A. So you see here, B implements A. That's called realization. And here's some coding examples. So you see I have a class called example. Here's the class's name. Then I have private int x. So here you'll see a dash x colon int. You'll see my constructor. And you'll see all the different types of method examples. So you see here's an abstract class defined with the default value. Okay, so they give that example, and here's an interface as well. Okay, so let's actually code some of this. What we're going to do is take the example from last class, okay, which is the pet store example. So I'm going to open up the code. We'll actually go through some of this so you know how to do it for the challenge. You'll see I have cat, dog, gender, licensed pet, pet, and trained dog. So we were going over this on Friday. For this challenge, the thing that I really recommend is to have 2 screens if possible. Have 2 screens, have the code opened on one, then have your UML open on the other with your reference sheet. Okay, so if you could have 3 screens, that'd be even better, but 2 is plenty. Have the code open on one like this. It's going to be kind of hard for me to do it. You're going to be using drawio.com. Or not .com, just drawio. Okay, so this is the tool you'll be using. And on here, we're going to choose Create New Diagram. Okay, so if I go to drawio.com, I'll do Create New Diagram. And I believe I chose to save it on my device. If it asks you where to save it, you can put Save on your device. I'm going to open up a blank diagram. You can give it a name. So for your challenge, you can give it a name. So you do like your paw print. And then what challenge it is. So it's UML. And I believe this saves it in XML. But you may not have to give it an extension. So you'd save your file name here. And now drawio doesn't save it automatically. So let's say I'm working on this. I need to save it and come back. So you save it on your local machine and then open the diagram to resume. Okay, so let's draw some of these. You'll see over here on the left, you'll see a UML section. That's the section we're going to be using mostly. And you'll see here I have different types of blocks. So I have a class. I also have class number 2. Now we need to specify the fields and the methods. So you'll see the third box over. That's the one that we're going to be using the most. If it's an interface, you may use class number 2 in some examples. I'm going to use the third one over, class number 1, and I'll just drag and drop. Now this tool you need to get a little bit familiar with it, otherwise it's difficult to work with. So the first thing, you'll double click in the name, and let's say we create the first one called pet. Okay, now pet, if I come back to this coding example, was abstract. So you can either highlight and do italic, but since on the midterm exam you're going to be writing that annotation abstract, I recommend you get used to writing it. So it's just kind of a habit when you get into the in-class midterm exam. So I put it italic still, but it's hard to write italic with your hand. Highlight. Yep. Yep. Control I. They also have a UI component up at the top. So I can highlight, and then you'll see it over here actually on the right. They'll have a text style. So I'll highlight it and then do an I over here as well. But I recommend you get used to, so go ahead and italicize it, but I recommend you still get used to writing these annotations. So on Mac, let me open this other thing up real quick. I set it over here on the challenge, I believe. So on Mac, it's Option / or Shift Option /. On Windows, you click Alt and type 174, or you click Alt, type 175. Because if I just do the character beside the M, it looks like this. If I do the real character, it looks like this. So you'll see there's a big difference there. Okay, so use the correct annotation. Instead of doing double less than, you're going to hit Option / or Option Shift /. So you see those annotations there. Okay. Okay. So what about on a laptop? You can't do stuff like that? Okay. Yeah, you can probably copy and paste it. Okay. What I can do is write some of those if you want to copy and paste them. Let's see, where are we at? So here's lecture 20. How about I paste some there at the bottom? So there's the left one, and on the new line, here's the right one. Can you copy those? Can you copy that thing and see if it'll work? So you did an Alt 174, it worked?
Yeah, it worked once, but now it won't work. I hit 1, I hold down Alt and I hit 1, and I hit 7.
And 4.
And it says leave site change.
You got to do 174. Not just 17, doing Alt 174.
Still telling me, asking if I want to leave the site.
Okay, try to copy it on from Canvas. Now, you'll see when I type this in, it's going to mess everything up. So you see a little diamond here. I can bring that class line down. Okay, so you want to make it nice and pretty. The hard part's when I'm actually writing these fields. And you'll see students, they'll do it, they'll write all the fields, and then all of a sudden it doesn't work. So let me show you an example. Let's say I have a field. If I go back to pet, you'll see I have a static int number of pets and a name. So let's write some of these. So here I have a private field. So private starts with a dash. And I have number of pets, which is an int. And number of pets has a default value of 0. So I'll say equals 0. Okay, now what students usually do is they're going to hit enter. They're going to hit enter and they're going to start writing the next one. So the next one was private string name. So I have private name, which is a string. And then they're going to move this line down. So I'm showing you what not to do. I forgot how to move this down. There it goes. Let's see. I think I can just drag it like this. Okay, there it goes. So you just drag it like that. Now, here's the thing. I need to underline only the first one. Well, I hit an enter. So now draw.io thinks this is one field. So I do a command U to underline. You can see it's going to underline everything. So it's thinking this is one big massive field on two different lines. So I only want to underline the first one, but it underlines everything. So instead what you do, let me go back to it being small, is, let me try to cut this one here. There's a arrow over here. So instead of hitting enter and having everything one field, you click the arrow. It's going to create a new field for you. So you see that's even a lot easier than me dragging it down like that. And now if I want to underline the first one, it doesn't underline the second one. Okay, so make sure you're using that arrow there. I've seen students, they get all the way done. They go to underline the first one, it underlines everything. They have to start over again. So then the second, click this arrow over here. Okay, this second one was name. So you just look at the code, private string name. Now come over here, here's private name, which is a string. And in this case, there's no default value. So I just keep going. I look at all of them. We can do the constructor. So you'll see it even gives you the recommendation. So you do the access modifier, then the method name, then the parameters, colon type. So let's do the constructor. So I look at the constructor. So you need to do these other variables up here. We'll move down to the constructor. The constructor is public. So I'll do a plus. Constructor needs the annotation. So I'll do an option backslash constructor. Option shift backslash to close it. Okay, TAs will be looking for these little annotations, so try to use them. And then the constructor is the same name as the class. And in this case, there's no return type. Okay, so you'll see I'm basically just writing the method signature. I'm not writing the implementation details. And then again, instead of hitting enter, you hit this plus symbol over here. You see I have another constructor, but this constructor has parameters. So it has name, which is a string. Okay, then I do a comma. Then it has int, so it has age, which is an int. Type, which is a string. And gender, which is of type gender. Okay, so now all of a sudden I have this big thing here. So you're going to want to make sure the box wraps around everything. So I'm going to drag the box over on the right. You may have to make it large like this. That's okay. On what part? Okay. Why do you want to change the font size? Okay. So did you hover over it and then go over here and do the it looks like it's working. But I think I would leave the 12-point font because this thing's going to get really big. And yeah, you're basically going to have a really zoomed in version. Or, sorry, a really zoomed out version. So it's going to be really, really zoomed out. So I wouldn't go much smaller than 12 points, actually. If anything, I'd go bigger on the fonts. But I would just leave the fonts as is. Okay, let's do two more of these here. Go ahead. You click this arrow over here? If you find a better way, let me know. Okay, here comes an abstract method. So abstract are a little bit different. You see it's public, abstract, string array, get core vaccines. So I'll do the access modifier, and then I'm going to do the method name. So get core vaccines. Okay, it didn't have any parameters, and it returned a string array. Now, abstract methods are italic. So I'll highlight the string, the text, and do a Control-I. But on the exam, you can't write this very easily, so go ahead and get used to doing the annotation. Just put the abstract annotation. So I recommend doing both, actually. I recommend to do both. Make it italic and write this annotation. So you're used to writing that on the exam. Okay, if you don't do it, that's fine, but then on the exam you'll forget to do it and we won't see it's italic. Here comes a static method. So here I have public static int get number of pets. So here's public. I'll make sure the italics is off. We'll do it in a second. It looks like it's bugging out on me. So this is get number of pets, which did not take any parameters and returned an int. Now static methods are not italics, so I'll remove the italics, but they are underlined. So I'll make sure it's underlined. Okay, you'll just keep going. So let's look at some, and you can move these around, so you can move these classes around. Okay, you'll see pet doesn't extend anything and doesn't implement anything, so that's at the top. So you put pet up at the top. On your example, the classes may be a little bit different, but conceptually it's the same. And then if I go into one of these, cat or dog, you'll see dog extends pet, implements license pet, and train dog. So let's take a look at that. So over here on the left, you're going to see a bunch of lines. If I do implementation, you'll see it's a dotted line with an open arrow. If I scroll through, you'll see generalization, which is going to extends. And that's about it. So I essentially have these two. Yep. So it's in the middle, and then the other one you need is on the last row on the left, second to the left. So let's take a look at these two. So I'm not going to draw out dog, but we'll put it out here. So here comes dog. And when you're writing these things, you're going to want to get this thing to click. So you see if I drag the arrow up, it'll turn green. Once it turns green, it's going to stay there. And then on dog, you'll see the little points there. So I'll connect them to one of the little points. Now if I move dog, the arrow will stay there and move with it. Or if I move pet, you'll see the arrow stays there. So make sure they turn green. So if you start to move stuff around, and actually you'll feel it pop there. You'll see it snaps to it. So snap it. Make sure you snap it so it stays there. You'll see in this case I didn't snap it, so when I move it, the arrow doesn't move with it. So dog extends pet and also implemented license pet. So let's say I had an interface called license pet. Okay, so this is an interface. You'll see the interface requires this annotation. A few things. You want to make sure the lines cross as little as possible. Okay, try to make them cross as little as possible so it's not so difficult to read. And then you'll see this one says extend, so that makes it really nice and pretty. So on the dash line, if you click in the middle, you can actually type something there. So I recommend typing implements. Okay, just make it nice and neat as possible. So make those two the same. So this one says implements, and this one says extends. Now, I could come over here and have these two arrows crossing like this, but try to make it cross as least as possible. The other thing is I could put this interface down here. but you'll see the arrows going down. Okay, that'll get points taken off. Make sure the arrows are always pointing up. It can be kind of diagonal a little bit, and it can be almost to the side, but try to make it going up as much as possible. So all the superclasses will be on the top, all the subclasses will be on the bottom. Try to have the arrows going as vertical as possible. If they're going in a downward motion, points will be taken off. Okay, because that doesn't show the inheritance factor. Okay, that's it for today.